24, we're just doing more practice with solving equations. So the first one's pretty basic. We have sine of x equals negative root 2 over 2. So sine of x is equal to negative root 2 over 2 in two locations in the unit circle. So tell me the two quadrants where sine is negative. Kenzie. Quadrant 3 and 4, is that what you said? Okay, 3 and 4. So we want sine to be negative, so we want the y value on our unit circle to be negative. So these two numbers. Okay, so that happens at 3 pi over, not 3 pi over 4, geez, 5 pi over 4 and 7 pi over 4. I know, she had quadrant 2 in my head. All right, so 5 pi over 4 and 7 pi over 4. So those are our two answers. All right, so on something like the next one, cosine squared x equals cosine x. Do you guys remember when we would have things like y squared equals y? How we would solve that? It's a little tricky. Like, people always forget how to do this. They always divide by y on both sides. Is that what you're thinking? And they're like, y equals 1.
Take the square root?
Nope, you can't take the square root either, because then you have the square root of y. That's not going to be pretty. Yeah, Hallie. Yeah, we have to get them on the same side. You would, like, subtract the y over and then factor the y out, because there's actually two places where when I square the number, I get itself out, right? 0 and 1. Does that make sense? So if you do this the wrong way is to divide by y, you would get y equals 1. You can't do that, okay? Y is not just equal to 1, it's also equal to 0. Does that make sense? So the same thing happens with these trig equations. We have to get everything on one side so we can factor out that cosine of x. So I'm going to have cosine squared minus cosine equals 0. Now, when I'm saying this, I'm saying cosine squared minus cosine. I'm writing cosine squared x, right? Right? There's always something. Like, it's kind of like logarithms. You can't be like, log equals 2. It's like log of what? Sine, cosine, and tangent are the same way, okay? And secant, cosecant, and cotangent. All right, so I'm going to pull out the cosine squared. Or the cosine, just cosine of x, I mean. So I'm going to have cosine of x, and then I'm going to have cosine of x minus 1 left. Do we all see that? If you multiply back in, don't you get cosine squared minus cosine of x? I'm also writing cosine squared. Have you guys wondered why I write cosine squared like that? I haven't even talked about that, have I? Instead of this.
Yeah.
Does that confuse you, like why I have the square there? If you write it this way, that means cosine of x squared. Okay, so we kind of sneak the squared in after the cosine, so we know that the whole cosine of x, the whole term, is being squared. Okay, so anyway, so we have cosine of x equals 0, and I have cosine of x equals 1. So on my unit circle, I want to know where my cosine of x equals 0. Well, cosine is equal to 0 in two locations, here and here. Right, the x value on the unit circle is 0. So those are x equals pi over 2 and 3 pi over 2. And then cosine is equal to 1 in one location, right? So our x value is 1 on the far right side of the circle. So that's going to be at 0. Should I write 2 pi as well? I could, but I'm not going to in this case. So let's look at the domain. And tell me why I don't include the 2 pi. Yeah, it's just a parenthesis. There's not a bracket around that 2 pi, right? Does that make sense? So we don't need to include it. Now, if you included it on accident, like on the test, I would still count it, right? It's fine. We'll just kind of look at your domain. Okay, so the next one. So I have 2 sine of x times cosine of x equals sine of x. So what this looks like is something like 2xy equals x, right? Again, if I'm trying to like factor something like this, I have to get everything on one side and set it equal to 0, and then I pull out the GCF. So that's what I'm going to do here. Yeah, Greta.
Sorry, why is it 0? Like, why is one of the answers 0?
Because of this point right here, cosine is equal to 1 at 0 because of this.
I guess we use because it's not radian.
0 is in radians. 0 is 0 degrees and also 0 radians.
Oh, okay.
Because it's like an arc length, right? Radians. All right, so we pull out the GCF of sine of x. When we do, we get 2 cosine of x minus 1. So kind of do it along with me. Set each piece equal to 0. So we want to know where sine of x is equal to 0 and where cosine of x is equal to 1 over 2. So you could do 2 separate unit circles or just one, it's fine. So sine of x is equal to 0 in 2 places on the unit circle. On the far right side and the far left side, right? So we're saying the y value equals 0. And so that would be x equals 0 and x equals pi. And then cosine is equal to 1/2. That's the x value, right? So we're saying go over just a little tiny bit to the right. So it would be these 2 locations. So it's like 60 degrees and 300 degrees. Okay, but what is that in radians? So we're pi over 3. And we're pi over 3 away from being at 2 pi. 5 pi over 3. So those are our 4 solutions. Okay, again, we don't need 2 pi. Brooke, are you dying?
No, I'm good.
Okay, so the next one I have cosine squared equals sine squared. Okay, on this one you could get them on one side and then you could factor. So I'll show you 2 ways to do this. So cosine squared, if I subtract the sine squared over, I get equals 0. And again, I can factor. That's now the difference of 2 squares. Do you guys know what I mean by that? Kind of like x squared minus y squared factors into x plus y times x minus y. Same idea. So this would factor into cosine of x plus sine of x times cosine of x minus sine of x. So we get 2 equations. So the first one we end up getting cosine of x plus sine of x equals 0, which means cosine of x is equal to negative sine of x. And the second one we get cosine of x minus sine of x equals 0. Can I skip that step? It's hard writing out all these. So what do we get? We get cosine of x equals sine of x, yeah. So on our unit circle, we're saying when is our x value equal to the opposite of the y value, right? That would be here and here. Those are the ones where the point is negative root 2 over 2 comma root 2 over 2. Do you guys see how the x value, negative root 2 over 2, if I multiply by negative 1, I get the y value? That's what it's saying. Does it make sense? And then this one was the one that was like positive root 2 over 2 comma negative root 2 over 2. You with me? So what are the x values for those? What are the, I gotta be careful saying x value, what are the angles in radians for those? Yeah, 3 pi over 4 and 7 pi over 4. And then this other one is saying, well, when are my x and y values exactly the same? And that happens at pi over 4 and 5 pi over 4. So we end up with 4 solutions. You can write them separate if you want, or put them all together. It doesn't matter. Go ahead.
For cosine of x equals sine of x, so it's like when is the x value equal to the y value?
Yeah. Yep. Another way that you could see it, so she's asking, like, I don't understand what this means when it's like cosine of x equals sine of x. So that is like, when is the x value equal to the y value? Or you could divide the cosine over and have sine of x over cosine of x and look at it that way. Well, now you're saying, when is tangent equal to 1? Tangent equals 1 when the x and y are the same, right? So you can think of it that way as well. All right, other things you can do. So there's not just one right way to solve these. So if I have this, many of you guys were probably tempted to take the square root of both sides, which you can. Like, you can say cosine of x equals sine of x. It's just when you take the square root, right? So let me write my squares on there and take the square root. What do I always write? Plus or minus. So if I have a plus or minus, what we would get is we would get the cosine of x with a plus or minus equals the plus or minus sine of x. And really writing it on both sides is kind of redundant. So even when you guys had like x squared equals 4, and I took the square root, I only wrote it on one side. Technically it is plus or minus x equals plus or minus square root of 4, which is 2. But we end up getting 2 answers. Does this make sense? Everybody look up here. So if I had positive x equals positive 2, I get an answer of 2. If I had positive x equals negative 2, I get an answer of negative 2. What if I had negative x equals positive 2? What's my answer?
Negative 2.
Negative 2. And if I had negative x equals negative 2, what's my answer? Positive 2. So I only get 2 answers anyway. I just need to do the plus or minus on one side. So I can wipe out one of those pluses or minuses, and then I'm straight to those 2 equations that I had. Does that make sense? So that one's legit. Like, you can take the square root of both sides. That's fine. Just don't forget that you have a plus or minus when you do that. Okay, next up. So this one. So I'm going to add the root 3 over and divide by 2. So I get cosine of 2x equals root 3 over 2. So let's see if you remember. So when we have a cosine of 2x, remember we're going to let our w equal 2x, and we're going to find w on 0 to 4 pi. 4 pi, nice. 4 pi. Okay, so I have an element of, this is the way that I write this. Fancy math words. W is an element of 0 to 4 pi, meaning w is the solution on 0 to 4 pi. You can write w is on 0 to 4 pi. So we're finding where cosine of w is equal to root 3 over 2. And that's in 2 places. Okay. It's on the right side of the unit circle, and they're the bigger numbers. So they're the ones that go out really far, like 30 degrees and 330. So this would be pi over 6 and 11 pi over 6. So those are our first answers for w. So I was tutoring someone yesterday, and they were having trouble with this 2 pi thing because they were like, oh, I'm going to add something, like, if I want to add 2 pi, I add, like, 8 pi over 4 every time. I'm like, no, like, it depends on what the denominator is, right? So in this case, if I'm adding 2 pi to both of these, I'm thinking of it as what? 6 over 6, which would be pi, so it's 12 over 6 for 2 pi. Does it make sense? So I'm adding 12 over 6. That's what I'm adding to each of those. So if I add 12 pi over 6, I get 13 pi over 6, and I get 23 pi over 6. Those are my 4 solutions. And that's equal to 2x. So if I want to solve for x, I divide everything by 2. So you guys pros at this now? Pi over 12, 11 pi over 12, 13 pi over 12, and 23 pi over 12. That one didn't involve much thought because none of the numerators were even, right? So we're just multiplying by 1/2. That's the same as dividing by 2. Multiplying by 1/2. Did I lose ya? Did you get it, Greta?
Yeah.
Yeah, of course.
So are we going to add 2 pi every time, or just in this?
It depends. In this case, since we had w was equal to 2x, we had to do 2 full rotations around the unit circle. Because look at our last answer, 23 pi over 12. That's smaller than 2 pi, right? Because I took my interval, which was 0 to 4 pi, and in the end, I halved it because I wanted to solve for x. I divided by 2. So it puts all of my answers on 0 to 2 pi then. So what if I had w was equal to 3x? Yeah, I want my answers to go from 0 to 6 pi, so when I divide by 3, I have everything on 0 to 2 pi. Does that make sense? Do you guys get that? Okay. So the next one. So again, you can get everything on one side, you can factor, but if you don't want to factor, you could take the square root. Let's go ahead and divide by 4 first, though. So I can take the square root, but when I take a square root, I can't forget that plus or minus. So I get sine of x equals plus or minus, and the square root of 1/4 is 1/2, yep. So I want my sine to equal plus or minus 1/2. So sine is equal to 1/2. The y value is 1/2 in 4 locations. Well, positive 1/2 and negative 1/2, right? 4 locations on the unit circle. Okay, so do you remember those 4 answers? So it's pi over 6. Yep, Greta's got it. The rest of you guys got it? You getting better at them? No, not so much. Did well on your unit circle quiz. You got it. Yeah. Yeah, so if you guys need help with the unit circle quiz, let me know. I'll help you. All right, so this one, so we have a sine squared and a sine, but it's not set equal to 0 this time. So I can't just pull a sine to the front in this case because it's equal to 1. And there's lots of numbers, an infinite number of numbers that multiply to be 1. I could have like 1/5 and 5, right? I could have negative 2/3 and positive 2/3. I don't know what their equals are. So we have to get everything set equal to 0. So I'm going to have 2 sine squared x plus sine of x minus 1 equals 0. And then I factor from there. So I factor into 2 sine of x and sine of x are going to multiply to be 2 sine squared of x. And then my last numbers need to multiply to be negative 1. So I need 1 and 1, but they need to have opposite signs. So let's look at our outer and inner swoops. So right now we have sine of x and we have 2 sine of x. We want to add those together to get positive sine of x. So we need a positive with the 2, or with the 2 sine of x, so with the outer term, and a negative with the 1. Does that make sense? You guys get it? So when I set each piece equal to 0, I get sine of x equals 1/2, and I have sine of x equals negative 1. So I just set each one equal to 0. I added 1 over, divided by 2. I subtracted 1 over, right? So on my unit circle, sine of x is equal to 1/2 here and here. So those are like the pi over 6 ones, the 30-degree ones, right? So I'm going to have x equals pi over 6 and pi over 6 away from pi. 5 pi over 6. And then sine of x equals negative 1. Well, that happens down here on the unit circle, right? So that one's going to be, so I get 3 different answers. All right, number 8 has a different interval, so it's on negative pi to pi. Inclusive, meaning including both negative pi and pi. Not like the last one that didn't include 2 pi, right? So we're going to go ahead and simplify. So I multiply the 2 in, so I get 2 minus 2 sine squared x minus 5 sine of x plus 1 equals 0. So I have negative 2 sine squared x minus 5 sine of x plus 3 equals 0. Does it bother you that the negative is out front? So we can divide everything by negative 1. So I get 2 sine squared x plus 5 sine of x minus 3 equals 0. This is a tricky one to factor. So go ahead and think about the factoring on it. Okay, we want the last terms to multiply to be negative 3, so we definitely need opposite signs, like one's a plus, one's a minus. And some of you guys might put like the 3 here and the 1 here, and you might be like, oh, I can get 5 if they're both plus, right? But again, they need to multiply to be negative 3, so that doesn't work. So the 3 can't go there, it has to go here.
Did you forget the 5?
No, my handwriting's just bad. That's 5 sine of x.
Oh,
Okay, good.
okay,
All right, so my outer needs to be 6 sine of x, and my inner needs to be minus 1 sine of x. Does that make sense? You guys get it? So as I start solving this one, I get sine of x equals 1/2, which is good. I get things there. So sine of x is equal to 1/2 would be those last 2 answers I had, which were pi over 6 and 5 pi over 6. But this next one is sine of x equals negative 3. Hallie's scrunching up her nose saying no. Why? It's not on the unit circle. The biggest that sine, or the smallest, I guess, since it's negative, the smallest that sine ever is at 3 pi over 2, the sine value is negative 1. This would be like down here. Okay, that doesn't happen. That's not on the unit circle. So if you try to do inverse sine on your calculator even, so if I try to do like inverse sine of negative 3 on my calculator yells at me. It says something about error domain. So this one doesn't work. So this one has no solution for that part. So our answers are only these 2. And that will happen sometimes. All right, try the next one. Brooke, put it away. All right.
So what's the difference between it the negative pi to pi and like.
Oh, yeah, so I didn't even do that, did I? So negative pi to pi. So our answers would be from here to here. So negative pi to pi. So the only, actually, not negative, that's negative pi over 2 to pi. What am I talking about? Negative pi around to pi. So all of our answers would be between there. Now, in this case, it was okay. Are those answers between, like, pi over 6 and 5 pi over 6? That's on that interval, right? But if I got an answer that was, like, over here, so let's say we got 5 pi over 4, that's not on the interval negative pi to pi. So what I would have to do is instead write that as negative 3 pi over 4. Like, use its coterminal angle. Okay, well, we'll have one that's like it, I'm sure. Okay, so basically, if you have something that's on negative pi to pi, maybe this answer will be like it. Let's do this one, and then I'll explain more. So this one I have tangent of x times tangent of x minus 1. So I factor out the tangent of x. That was just the GCF, right? So when I set each piece equal to 0, I get tangent of x equals 0, and I get tangent of x equals 1. So tangent is equal to 0 when sine of x over cosine of x is equal to 0. In other words, sine of x equals 0. So sine is equal to 0 in 2 locations, here and here. So my answers to that would be 0 and pi. Okay, but tangent of x equals 0 when sine of x over cosine of x, or sorry, tangent of x equals 1 when sine of x over cosine of x equals 1. Which means, in other words, sine of x is equal to cosine of x. So there are 2 locations on the unit circle where that's true. Okay, that's going to be here and here, which are x equals pi over 4 and 5 pi over 4. But our issue is that we want this to be on negative pi to pi. Okay, that answer, 5 pi over 4, is bigger than pi. You get it?
Yeah.
So we want to write it in its coterminal form. We want to keep adding 2 pi or subtracting 2 pi until we get an answer that is on that interval. So what I'm going to do is I'm going to subtract out 2 pi. So when I subtract out 2 pi, I get x equals pi over 4. And then I have 5 pi over 4 minus 2 pi. Well, 5 fourths minus 2 is 5 fourths minus 8 fourths. What do I get? Negative 3 pi over 4. Is that between negative pi to pi? It's here, right? So that works. Negative 3 pi over 4. Does that make sense? So, I don't know. It's not like super important. Calculus is usually on 0 to 2 pi. But it's just knowing how to write things in different forms, really, is what it's saying. Sure. You could have 0 to pi, you could have negative pi to pi, 0 to 2 pi. Like, there could be lots of answers. All right. So the next one. So I have sine of 2x equals root 3 over 2. So this is, I think, one that was on your homework several times, twice. So in this case, you would let your w equal 2x. You'd find everything on 0 to 4 pi, and then you would divide by 2. Can we skip that one? We did that one a couple times. All right, so how about this one? Cosine of 3x is negative 1/2. Sorry, did you not have that one on your homework done? You skipped the one on your homework, and now you're like, no. Oh, that's sad. I'll help you after. All right, so cosine of 3x equals negative 1/2. So this one we're going to let w equal 3x. So we're going to do cosine of w equals negative 1/2. And we're going to find w on, so w is an element of, is how I write it. You don't have to write it that way, it's fine. We're going to find w on 0 to 6 pi. So we're tripling the interval, because in the end, I'm going to divide all my w's by 3. So when I divide them all by 3, then all my answers will be on 0 to 2 pi. So cosine of w is negative 1/2, means I have 2 locations on the unit circle, so there and there. Okay, so think to yourself, what are those values? So those values on 0 to 2 pi would be just 2 pi over 3 and 4 pi over 3. Yeah, we're going to triple. So we're tripling here. Is that what you're asking?
Yeah.
So whenever you see 3x, we're tripling. If you saw 2x, you double. 4x, quadruple. 8x. Yeah, multiply by 8. Because they're all looking at me like, please don't give us an 8x. I'm not going to give you an 8x. You're fine. I'll give you a 2 or a 3. All right, so we need to go 2 more rotations around the unit circle. So I want this answer, which is at 2 pi over 3, but I want to go around one more time. Well, 2 more times, actually. So I'm going to go around. I'm going to add 2 pi. So if I'm getting common denominators, I'm really adding 6 pi over 3, right? So my next 2 answers are going to be, if I add 6 pi over 3, I get 8 pi over 3 and 10 pi over 3. You with me? Okay, do it again. Plus another 6 pi over 3. So I'm going to add that to these ones. So I get 14 pi over 3 and 16 pi over 3. Those are my 6 different values for W. So W was really equal to, 3x. So I divide all my answers by 3 to solve for x. This is not hard. You guys can do this, all this grumbling. All right, so I get 2 pi over 9, right? Because I'm multiplying by 1/3, same as dividing by 3. I get 4 pi over 9, 8 pi over 9, 10 pi over 9, 14 pi over 9, and 16 pi over 9. Those are my 6 solutions. So on number 12, are you guys excited? It's only 2x. Yeah. All right, this one actually has more answers than this last one, though. This one will have 8 answers. Why will it have 8? Because you're like, it's a 2x. It should only have 4, right? Yeah, because of the squared. Okay, so I'm going to let my W equal 2x. And I'm still finding W on, I'm doubling the interval this time, so 0 to 4 pi. So I'm going to have 4 cosine squared W minus 3 equals 0. I subtract the 3 over and I divide by 4. I then take the square root, and when I take a square root, I need plus or minus. So I get cosine of W equals plus or minus, how does that simplify? Yeah, square root of 3 over 2, exactly. So the original problem has 4 solutions. And then if you have W, right, you're doubling the interval, you have 8. So we're going to have these 4 locations. So over really far to the right, so big number, small number, big X, small Y, right? Cosine is what we want, the X value. So we get W equals, all right, can you get the first 4? Pi over 6, 5 pi over 6, what's the next one?
7 pi over 6.
And the last one?
11 pi.
Look at you guys, so smart. All right, now we want to add 2 pi to each of those answers, one more rotation. So I'm adding 12 over 6. So if I add 12 over 6 to each of these, I'm going to get keep going, don't make me think. All right, and then you're good. So now if I want to divide them all by 2, right, because this was 2x, I get x is equal to, do you just want to do it all over 12? Will that make you happy?
Yeah.
So we have pi over 12, 5 pi over 12, 7 pi over 12, 11 pi over 12, 13 pi over 12, 17 pi over 12, 19 pi over 12, and 23 pi over 12. That's really bad notation. Don't ever do that. But those are our answers, and that's it. So your homework is bingo.